Okay, now step 2 of analysing the truss structures. We've previously worked out our reaction forces, and we're going to start from the left joint and slowly work our way through all those joints from left to right. What we have initially is a reaction force known of 667 newtons. We know there's a member there which is going to be acting against that joint, and we know there's a member there acting at that joint. So the best way to do this is just to look at these forces. We have a force there which we know is 667 newtons. We have the force that must be directed along that member. If it's going to oppose the reaction force, a bit of thinking there is going to clearly make us understand that it must be acting downwards, and because of the angle there, downwards and to the left. And then along that bottom member just there, we have the final force there. If the member from the top is acting down and to the left, obviously if that joint isn't moving, this force must be acting towards the right. Now, if we look at that force, look at that diagram, we can do a couple of things. We know the angle at the center there is 50 degrees, so we know that the first force, we can work out its components, so let's write them in now. It must be going down, and it must be going to the left. If we call that F1, then it's going to be F1 sine theta, because sine 50 degrees just there. That's going to be opposite, so that component is essentially opposite of that angle. And this one is going to be F1 cos theta. Use a slightly different colour here. The force going directly to our right, let's just call that F2, and it's obviously already acting horizontally, so let's keep it as F2. Now we're working. Let's give ourselves some more space. We know that that joint isn't moving, so therefore we know that the vertical forces are balanced. That is, we know that F1 sine of, let's put 50 degrees in already, sine of 50 is going to equal to that reaction force, 667 newtons. From that, very quickly, F1 is 667 divided by sine of 50. And that's 870.7, so let's just round that up to 871 newtons. Now, that's balancing the vertical forces, or balancing the horizontal forces. We know that F1 cos theta is going to the left, F2 is going to the right, so obviously F2 is going to equal F1 cos theta. So F2 equals F1, which is 871 times cos of 50. And that equals, and that's 559.9, let's make that 560. So 560 newtons. Now the final thing to look at here is what that means for compression of tension in our members. We know that F2 is pulling the joint to the right, so therefore the joint is trying to pull the member across. So that stands to reason that the member there has got to be in tension. Here the member is pushing the joint down, that means the joint's pushing it back, which means that it must be pushing that member into compression. So let's label those forces there. So quick look at them again. one at the top was 871 newtons in compression. Let's keep blue as compression. So that's 871 newtons in compression. And the one down the bottom, well, let's make a red for tension, was 560 newtons in tension. We'll do the next one very soon.